Okay, so in this video we're going to be going through reverse percentages. Now there are two different types of questions that you can get. So we're going to start with the first two examples, which is essentially just saying that the percentage of these people have blonde hair, for example, for the first one, and then we've got to work out then how many there were in total. And then later on we're going to be doing reductions and increases. Just because also they can come up with those sorts of questions as well. We are going to do a calculator bit as well, so just make sure you've got a calculator. I'm going to show you different ways. So for 1 and 2 I'm just going to stick with non-calculator just because it's easier, and generally it can be in the non-calculator bit as well. And then later on for the increase and decrease ones, I'm going to show you one way without a calculator and then one with, so you just have the ability to pick which method you want, but I think most people generally like to do the non-calculator way. So they do become quite wordy, so just sort of be careful of what you're reading. If you're someone that looks at words and can't really understand the bits that are important, which is me, just highlight the bits that you think are important. So for example, for the first bit, it says that 30% of all the children have blonde hair, so that must be important. We're told that 6 students have blonde hair. We need to work out how many children there are in the class altogether. Okay, so it's saying that 30% are blonde. Okay, so this is the people that are blonde. Okay. But it also says that there are 6 students who have blonde hair, which means that the 30% must be the same as the 6 children in that class. Okay, so the aim is all the children in the class must be 100%. So it's a bit like when I first did percentages, if you've watched the video before, 100% is always the total. Okay, so we need to get from 30% to 6. So it's similar to when you do percentage of amounts. So I'm going to try and find 10%. So just looking at 30 to 10, so to get from there to there, I would have to divide by 3, because 30 divided by 3 gives you 10, which means you also need to do the same on the other side. So 6 divided by 3, which is 2. Okay, so 10% is the same as 2 children. And then we've got to then find 100%, because that's going to be all of the children in the class altogether. So to get from 10 to 100, we must then multiply by 10, which means I also need to multiply this side by 10. So that means that there is going to be 20 children altogether in the class. Okay, so for the next one we're going to do something very similar. Okay, so I'm just going to move it up a little bit. So again, this one's talking about chocolate cake, just because I like cake. 5.2 grams of fat in that cake. Okay, we're also told that 13% of the cake is the fat. Okay, so we're then told the percentage and we're told the amount of fat. So that means that those two must be the same amount. So they must be equal to each other. So 13% is 5.2 grams. Now, when it comes to slightly harder numbers like this, the easiest way is always to find out what 1% is. So 13, to get to 1, you would just divide by 13, because anything divided by itself would give you 1, which means I would do the same on the other side. I want to say it's 0.4, but I'm just going to quickly check. So 5.2 divided by 13, and before, no, this isn't the calculator bit, this is just sort of to make sure I'm doing it right. Yeah, 0.4. Okay. And then we obviously need to find 100%. So again, we want to find the total mass of the cake. So it's just asking for the weight of the cake, okay, which must be 100% of the cake. So to get from 1 to 100, we must multiply by 100, which means I multiply this by 100 as well. which is 40 grams. So the cake has a mass of 40 grams. Okay, now you don't need to do the wordy bit at the end, it's just because it looks, it just sort of looks clearer when we're doing it. Okay, so just going to move on slightly harder. So these ones are now dealing with reductions, or reductions just as the same as decrease, but also increases. Okay, so I'm actually going to split the page here just in two, because I'm going to do it two ways. So I'm going to start with the non-calc way, and then I'm going to do the calculator way. Now this one's got nice numbers, so it means I can do it in either way. The next question's slightly harder, as in the percentage is a bit more tougher, so it means that it might be a little bit harder to do it without a calculator, but again, it's the same principle. So I'm just going to go through. So a bag's for sale for £78, so that's what it costs now when it's in the sale. 35% reduction of the normal price. Okay, what is the price of the bag before the reduction? Okay, so thinking before, normally the normal price would be 100%. Okay, so 100% would be the cost of the bag before the sale. But if it's in a reduction of 35%, that means 35% has been calculated and it's been subtracted from the 100%. So actually there's only 65% left. Okay, so that 65% must be the same as the cost of the bag in the sale, which is 78. Okay, once we've got to that, we then do something very similar to what we've done in EG 1 and 2, where our aim is to get back up to 100%. So there's different ways of doing it. I'm going to find 5%. So 65 divided by 13 gives you 5, which means if I divide that by 13, I get 6. Let me quickly just check. Doesn't even work anyway. 6. Okay, and then we want 100%. So 5 times 20 would give me 100, which means I then need to multiply the £6 by 20 as well, and that gives me £120. So that was the cost of the bag before the sale. Okay, now the calculator way deals with multipliers. Okay, so we need to find the multiplier if it's being reduced / decrease, if you prefer the word decrease. So decrease by 35%. So in a previous video I did show you how to do this. So to find the multiplier when you decrease, we do 100 take away 35, which is 65. Okay, now these are all percentages, so it's similar to what we did for part with the non-calculator. But to find the multiplier, you then need to divide it by 100. So we do 65% divided by 100, which is 0.65. Okay. Then because you want to find the price it was before it got reduced, normally we would just multiply by the multiplier, hence the name. But if we're doing the reverse of it, this time we actually divide by the multiplier. Okay. So you just type that into a calculator, so 78 divided by 0.65, and you get 120. Okay, so in the next example, I'm just going to do it the multiplier way, and you'll see why we divide rather than multiply. Okay, so for the next one, I'm just going to draw a little diagram. So I'm just going to do it calculator way. But again, it can be done non-calculator. Okay. Right, so we've got the same house with no windows. So we've got 2019, 2020. Okay, so house prices are increasing. So increase means it's going to be getting bigger by 12% from 2019 to 2020. The house cost in 2020 was 168,000. So I'm just going to write that under here. 168,000. Okay, and we need to work out the price it was in 2019. So what we would normally do, let's say that we knew the amount in 2019, we would multiply that by the multiplier, which we're going to work out in a second, and it would give us this amount. Okay, so I'm just going to start off with finding the multiplier. Okay, so again, we always start with 100, and it's been increased by 12%, so we're going to add 12% onto 100, and that gives us 112%. Again, it needs to be the multiplier, so we then need to divide that by 100, which gives us 1.12. Okay, so to get from the 2019 to 2020, we would multiply by 1.12. Okay, but the issue is we're not going from 2019 to 2020, we're going backwards. So we're doing the reverse of what we would normally do. So the reverse of multiplying would be dividing. Okay, so for the 2019, it will be the 2020 price, so 168,000, divided by the multiplier 1.12. Okay, so 168,000 divided by 1.12, we get the answer 150,000. Okay, so it's just making sure that when we're doing the reverse, so when we're going back in time or back to the previous price, for example, you always got to divide by the multiplier, okay? If you prefer the non-calculator method, so what I did here, then you can stick with that and it does work for everything. It's just whether it's easier for you, but that's your decision.